Dear students, today we see about the important topic for the first year student, that is orbital hybridization. So in the subject chemistry, orbital hybridization or simply the hybridizations is the concepts of mixing atomic orbitals to form the new hybrid orbitals. So these new form orbitals they have with different energies, shapes and so on. Then the component atomic orbitals. When two or more atomic orbitals are the mix to each other, we get new hybrid orbitals, but this hybrid orbital has different energies and they have also the different shapes than the starting atomic orbitals. For these hybridizations, the pairing of the electrons to form the chemical bonds in the valence bond theory. So this hybridization is done according to this valence bond theory. For example, if we take in a carbon atom which forms 4 single bonds, we have known that carbon atom it forms the 4 single bonds. The valence shell s orbital combines with 3 valence shell p orbitals to form 4 equivalent sp3 hybrid orbitals in a tetrahedral arrangement around the carbon to bond to 4 different atoms. Hybrid orbitals are useful in explanations of the molecular geometry and atomic bonding properties are symmetrically disposed in the space. Usually, hybrid orbitals are formed by the mixing atomic orbitals comparable energies. So these orbitals are the model representations of the behavior of the electrons within the molecules. In the case of simple hybridizations, this approximation is based on atomic orbitals similar to those obtained for the hydrogen atom, only neutral atoms for which the Schrödinger equations can be solved exactly. For the heavier atoms such as the carbon, nitrogen and the oxygens, the atomic orbital used are the 2s and the 2p orbitals, similar to excited state orbitals for the hydrogen. Hybrid orbitals are assumed to be the mixtures of the atomic orbitals superimposed on each other in various proportions. For example, in the methane, the carbon hybrid orbitals which forms each carbon hydrogen's bond consists of 25% of the S characters and the 75% P character and is thus described as sp3. Read as sp3 hybridized. Quantum mechanics describes these hybrid orbitals as an sp3 wave functions to the form where n is a normalization constant and is a orbital directed along the carbon H axis to form the sigma bond. The ratio of coefficients denoted in a general is examples. Since electron density associated with an orbital is proportional to square of the wave functions, the ratio of p characters to the s characters is lambda square is equal to 3. The p character or the weight of the p component is n square and lambda square is equal to 3 by 4. So there are the different types of the hybridizations are also the present, that is sp3. then sp2 or the spx or the dy or the spx. So depending upon the types of orbitals are they mix, so these hybridizations are also the formed.